So there's this crazy story going around. NASA might actually get back in touch with the Voyager 2 probe, which everyone thought was totally lost. They picked up a super faint signal, like a tiny heartbeat. People are wondering if NASA is hiding something big about Voyager 2. Get this, the probe ran into something so weird out there, it could make NASA do something about it for years. For ages, we've been hoping Voyager 2 would make it to deep space and still have enough juice to send back cool info. Voyager 1 did it back in 2012, and now Voyager 2 is starting to do the same in 2018. Even Joe Rogan is talking about it, wondering why NASA would even think about shutting down such an important mission. Is it aliens? A weird space thing? Something totally out there? Get ready to find out some strange stuff about Voyager 2's last days before NASA decides if they're going to pull the plug on it. Voyager 2's story started way back when we were super curious about space and wanted to explore beyond our solar system. It launched on August 20th, 1977. It was an automated probe, and it actually launched a few weeks before its twin, Voyager 1. Voyager 1 was built to go faster, but the engineers at NASA's Jet Propulsion Lab in Pasadena, California, really wanted to check out the outer parts of our solar system and figure out the giant planets that we didn't know much about. The Voyager 2 launch happened because of this rare lineup of planets that only happens every 176 years. The spacecraft could use the gravity of each planet it passed to speed up, which made the trip to outer space quicker. It was seriously a once-in-a-lifetime chance, and the planners knew they couldn't miss it. Even though Voyager 2 launched first, they called it Voyager 2 because of the route it was going to take. This route let it swing by Uranus and Neptune later on, though the flight was a bit longer. When they first made Voyager 2, they thought it would only work for about 4 years. It was mainly supposed to check out Jupiter and Saturn. The spacecraft had tools to study stuff like magnetic fields, plasma waves, and cosmic rays. No one thought Voyager 2 would still be interesting people over 40 years after it launched. Even the original team was cautiously excited, not sure how far the mission would go. Back in the 1960s, this aerospace engineer, Gary Flandreau, saw that the planetary alignment could make the mission work. He did the math and saw that Jupiter, Saturn, Uranus, and Neptune would line up so a single probe could visit them all using gravity to get around. It saved NASA both time and money because a normal trip would have needed way better tech and taken way longer. Even though it was cool, some people were skeptical. They wondered if the spacecraft could even survive the asteroid belt and Jupiter's intense radiation belts. Spacecraft in the past had a hard time with that stuff. But NASA kept going, using what they learned from the Pioneer probes. The point was to get new info about the giant planets and learn as much as we could. NASA didn't just make one spacecraft. They made two that were almost exactly the same, but with different flight plans. Voyager 2's longer trip to Jupiter would let scientists watch the planet for a longer time, which helped with the spacecraft's even bigger goals. It was a risky plan, but they really wanted to find stuff out. Little did they know, Voyager 2 would not only make it, but it would keep working way longer than anyone expected, spending most of its time at the edge of the solar system. Voyager 2 was designed with the tech that existed in the 1970s, so how well it's held up tells you how advanced it was for its time. Its memory was only 69 kilobytes, which is a joke now. Modern smartphones blow that away. But even though it didn't have much to work with, Voyager 2 was built to last. The systems had backup plans so that any kind of failure wouldn't kill the mission. The hardware was made to do simple stuff without using too much software, which was smart since the tech was so limited back then. The spacecraft's memory and how much it could handle might seem basic now, but the systems were made to be super strong. It had to deal with crazy conditions. Shaking from the launch, radiation near Jupiter, and freezing cold in space. One of the most interesting things about Voyager 2's design is the data recorder, which used an 8-track tape system to store data before sending it back to Earth. That sounds old school, but it worked reliably in space. Even with the huge distances, Voyager 2 still sends signals back to Earth. Each bit of data takes over 18 hours to get here, and the delay gets longer as the spacecraft moves further away. Talking to Voyager 2 is tricky and takes time, considering the sensitive tools it has and how little power it's working with. The spacecraft gets its power from radioisotope thermoelectric generators, RTGs, which use plutonium to make electricity. As the plutonium breaks down, the power goes down, so the engineers have to keep deciding which systems to turn off to save power. Even with less and less power, Voyager 2 has lasted way longer than anyone could have guessed. It's a testament to the smart folks who designed it. The spacecraft can fix problems on its own if it loses contact with Earth. Being able to adapt and keep working despite its age and the crazy environment has kept it alive. As Voyager 2 kept going, it got to Jupiter, which was a really cool part of its mission. Even with the challenges like the planet's intense radiation belts, the spacecraft got a ton of data and cool pics of Jupiter. Even though it didn't get as close as Voyager 1, it gave scientists a better look at the planet's magnetic field, plasma waves, and charged particles. The cameras took awesome pics of Jupiter's swirling clouds and the Great Red Spot, a huge storm that's been going on for centuries. The data helped scientists better understand Jupiter's magnetosphere. Voyager 2 showed how Jupiter's massive magnetic field interacts with the solar wind, which gave scientists a new idea of how such a strong magnetosphere acts. But the excitement came from Jupiter's moons. Voyager 1 had already found active volcanoes on Io, and Voyager 2 helped prove it by taking detailed pictures of the eruptions. The spacecraft also found info on Europa's icy crust, hinting at a possible ocean under the ice. Other moons, like Ganymede and Callisto, were studied, and they showed their own unique histories through their craters and grooves. Each moon was a cool world of its own, which no one expected and raised a lot of questions for scientists. Voyager 2's flyby of Uranus gave scientists a lot of new info. They studied the planet's atmosphere, which has a lot of methane. Voyager 2 also looked at the planet's ring system, which is smaller and harder to find than Saturn's, but it showed how rings form and move. The flyby let scientists get close-up pictures of Uranus's moons, which showed different surfaces and geological features. Miranda, one of Uranus's moons, had a weird, broken-up surface that made scientists think it had a rough history. The flyby at Uranus was really helpful, but it also made the mission harder. The spacecraft had to deal with less power as the plutonium in its RTGs broke down over time. The team worked hard to manage the spacecraft's energy, turning off things it didn't need and making sure the important tools kept working. The cold in deep space, especially near Uranus, meant the team had to keep the spacecraft's heaters working so things wouldn't freeze. Despite the problems, Voyager 2 kept working well so it could finish its observations and keep going. After it swung by Uranus, Voyager 2 kept going towards its next target, Neptune. The spacecraft didn't have as much power, but the team wanted to keep it going. As it got further from the Sun, the spacecraft couldn't make as much power, but the team made sure it could still send data back to Earth. And that takes us to where Voyager 2 is now. The probe's journey has gone beyond what people thought, and it's a symbol of our curiosity, innovation, and never giving up. Even though it's slowing down because of power problems, the info Voyager 2 has sent back has taught us a lot about the outer solar system and beyond. It shows how far we've come in space exploration and how much there is left to find out. The data from Voyager 2's Uranus flyby proved that Uranus's magnetic field was tilted, but in a strange way. Instead of being in the center of the planet, the magnetic field was off to the side, so its magnetosphere wobbled around. This made people wonder about what was going on inside the planet that could make such a weird magnetic field. Voyager 2 also gave a better look at Uranus's faint ring system. Ground-based telescopes had sort of seen them, but the spacecraft's close-up pictures made people understand the ring's shape and what they were made of better. Uranus's moons also had surprises. Before the flyby, scientists thought the moons were just boring, icy rocks with craters. But detailed pictures of Miranda showed a crazy surface with big canyons, ridges, and weird patterns. The landscape looked like it had been through a lot, like melting and tectonic forces. Other moons, like Ariel, Umbriel, Titania, and Oberon, weren't as wild as Miranda, but they still showed signs of geological activity in the past. The data from Uranus also changed what people thought about its atmosphere. Scientists thought the planet would be pretty boring because it's so far from the Sun, but the pictures showed faint clouds, which meant there was weather going on. Even though Uranus doesn't get much warmth from the Sun, it wasn't as calm as people thought. Infrared measurements showed that Uranus might be losing heat slowly, but the details of what's going on inside are still being discussed. One of the best things about the Uranus flyby was that it showed how an ice giant like Uranus is different from a gas giant like Jupiter or Saturn. Uranus has more ice, like water, ammonia, and methane than the bigger planets. The gravity and magnetic field data that Voyager 2 got showed that Uranus has layers inside, a rocky core, an icy middle, and an outer layer. This layered structure gave clues about how the solar system formed. But since it was just a single flyby and the time to measure stuff was short, there were still a lot of questions. After it did its thing at Uranus, Voyager 2 used the planet's gravity to change course, getting ready for its trip to Neptune. This trick was important because it gave Voyager 2 the power it needed to get to the furthest major planet in the solar system. The success of this move proved that NASA's Grand Tour mission could work, and the Uranus flyby was seen as a win for the technology. In August 1989, Voyager 2 got to Neptune, finishing its grand tour of the outer solar system. It was the first time anyone had seen Neptune up close, and Voyager 2 working so far from Earth was a huge deal. By the time it got to Neptune, the spacecraft had been going for 12 years, which was way longer than they had planned. Neptune's blue color, fast winds, and crazy atmosphere gave scientists a lot of new data. Voyager 2's pictures showed swirling clouds, big storms, and a large dark spot that looked like Jupiter's Great Red Spot. Scientists didn't think Neptune's atmosphere would be doing much, but Voyager 2 found that it had active weather, which was driven by Neptune's internal heat. The spacecraft also recorded the fastest winds in the solar system. The dark spot disappeared in later photos, which showed that Neptune's atmosphere changes a lot, even that far from the Sun. Voyager 2 also studied Neptune's magnetic field, which, like Uranus's, was tilted. This supported the idea that ice giants make magnetic fields differently than gas giants. Voyager 2 also found Neptune's faint ring system, which was made of arcs instead of complete rings. Scientists thought that these arcs were probably caused by small moons or other gravitational stuff. Neptune's largest moon, Triton, stole the show. Voyager 2 found that nitrogen geysers were shooting out from Triton's surface, which was surprising since it's so cold. The moon's surface had weird terrain and cryovolcanic activity, which went against the idea that icy moons were geologically boring. Also, Triton orbits backward, which made people think it might have been caught from the Kuiper belt. After it did its thing at Neptune, Voyager 2 finished its tour of the planets and started its trip to deep space. The spacecraft, heading towards the edge of the heliosphere, had already done a lot of great things. As Voyager 2 went past Neptune, it got to the outer parts of the solar system, where the sun's wind makes a protective bubble called the heliosphere. The heliosphere, made by charged particles from the sun, protects the solar system from some cosmic rays. Scientists weren't sure where the heliosphere ended, guessing it was somewhere between 50 and over 100 astronomical units. Voyager 2 had tools to see changes in particle density, temperature, and magnetic fields. These tools gave cool info about how the solar wind slowed down and lost pressure as it got further from the sun, and how the heliosphere dealt with cosmic rays from outside the solar system. As Voyager 2 went further into deep space, it got more info about the heliosphere's edges. It went through the termination shock, where the solar wind slowed from superfast to slower than the speed of sound. The edge of the heliosphere moved because of solar activity, and Voyager 2's data helped scientists see how solar cycles changed the shape of the heliosphere. The spacecraft also saw changes in plasma, cosmic rays, and magnetic fields, which proved that the heliosphere is always changing, not a fixed thing.